Hello friends, today I want to talk to you about something I'm finding particularly interesting. It's the companionship of two of my favourite programming languages. We've got Elixir, it's a programming language I use in my day job. It's a functional programming language with the full power of the beam behind it, concurrency, actor model, all of the good buzzwords which make for amazing distributed systems. We've got Elixir, all the good stuff there. But then we've also got Zig, a low-level systems programming language where you have full control of the memory. In the same realm as C or Rust, but without the build system issues of C or the shoot yourself in the foot constantly with the borrow checker of Rust, Zig is a pretty nice language for just getting some stuff done. So I wanted to see how they can be joined together. How can we have an Elixir app going in and calling functions from Zig? It's completely possible. I've heard of it happening before. I've seen some examples and I want to implement it myself. So come along for the ride. Let's have fun. So the mechanism that will be used for going from Elixir and loading in that low-level native functionality from Zig is something called NIFs, which comes from Erlang, which Elixir runs on. So Elixir it's really just like a nice face on top of Erlang. Erlang and OTP are the sort of like the underbelly of Elixir. It's what gives Elixir its power, really. Elixir is just a nice syntax on top of it more than anything else. So you have Erlang. It's had the capability of running native code within it using this mechanism called a NIF. So a NIF is a natively implemented function, maybe? NIF. Natively implemented function. I was right. So where do we start? Let's create a new mix project. We'll call it nifty. That just scaffolds some very basic files for us. If we cd into that, and then we can run our IEX session, we'll just load it with -s mix, so it loads the mix project that we're currently in. And so then there we go, we're in our nice Elixir environment. Perfect. So we have our Elixir environment with just a first very basic module that doesn't do anything, it just says hello world. So we can show that will run. If we go into IEX, we can do nifty.hello, boom, world, lovely. Okay, so we can exit out of that. We're also going to need some Zig files. So to initialize a Zig build project, we're going to use Zig init. And if we just show with help what that does, it initializes a Zig build project in the current working directory, which is perfect. So we'll do Zig init. And there we go, we've got a Zig build zon, which is their kind of like package file, and a source directory which contains a main.zig and a root.zig. So we can hop in and see those. So in main.zig, this is the entry point to the entire output from the module. We'll see that in the build zig in a second. But this is just going to do a print statement, go and get the standard out, and then write that basically to standard out. So we can do, if we do zig build, that's going to build Zig for the first time. Give it a second. If we just do an ls tree, we can see those are the underscore build directory is all the compiled Elixir code ready for the beam. That's the beam bytecode right there. But then we've also got this Zig out directory, which has a binary, nifty, and a library compiled output. So we can we could run that. Nifty. And there you go, it ran that print statement for us. All your code base belong to us. If we wanted to just run it immediately though, we could do zig build run, which just runs it immediately after building. Zig as a build tool is incredibly flexible. It's designed so that it can really nicely interop with C or basically any other system and produce binaries or libraries based on that, which makes it a really good choice for exactly what we're trying to do, which is compile it for a very specific kind of environment. The definition for how Zig builds things is in the build.zig at the root of the project. So let's hop in there. This is all the boilerplate that came with it when we did the init. In here, you can see that it's adding a static library, which is located at source root Zig. We haven't been there yet. Let's hop in there. We can just see it's got a simple adding function and a nice test for it. So we'll hop out of there. Back in the build Zig, we've got, so that's the library definition, and then it's installed as an artifact into the build directory. And then you've got this executable, which is based on source main.zig, which is also installed. And then a new command is set up, which for run with a dependency on installing everything, any arguments pass through to it. And then there's a step, this run, which is when you do Zig build run, that run is what comes in and is a step in the build Zig. You've also got a similar thing for unit tests. So it goes through and adds any tests which are in that file. The same with the source main Zig, and then adds steps so that you can do the Zig build and then test, which will run the tests as well. Just let that compile. No output means no problems. We can prove that by, if we go back to, if we just hop back into NeoVim, we'll just go into the root, and then we'll change this to be wrong and exit back out. We'll run the test again, let it build, and then there we go, we see an error. So that proves that it's working. Okay, so we have two separate projects here. Basically, we have Zig and we have Elixir. We need to write something that Erlang, Elixir, the beam, is going to be able to understand from the Zig output. We'll start by completely clearing out our build Zig. There's a load of stuff in here, and I'm not too interested in the tests, etc. I'm just going to get rid of literally everything. I've cleared out everything except from the target and optimize. These are two just standard options where we can basically, from the outside, specify what's the build target and what level of output are we expecting. Do we want a highly optimized output, or do we want something which is just fast compiling? So it's kind of convention that you would have those in there, and all of the downstream commands we're going to write here are going to need these two values. So we're going to leave that as it is. So next we're going to offer a step. I'll just call this NIF step. This is going to be where this is going to be a subcommand of our build Zig, which is for specifically building this NIF. So we'll say B, which is the standard build object, build step. We're going to name it NIF, and we will give it just a cheeky description. Compile our NIF for Erlang for the beam to consume. We have our step. It's not actually being used yet. Next, we are going to add a shared library. Which will have some options. So the name is going to be, we'll just call it nifty. The optimize is that optimize from above there, so that we just pass that through. The target, again, is just that target from above. We're going to set up the root source file is going to be that source root Zig file, but we need to wrap it in a special lazy path so that it doesn't. We need to wrap it in a special lazy path. We'll say source root.zig, thank you. And we will also link libc, because we're going to need that for Erlang. So we need to better provide Zig with the types that come from Erlang. Like Erlang has special types around everything that it uses. It has special functionality that it exposes to NIFs, which will allow us to communicate back to the calling process in Elixir. So we need to install that library. The library will be, since I have Erlang installed on my system, that library, that C library, the header, will be available somewhere, but we need to find it. So to save some pain, I will include the special incantation here, which will get you your current library include folder using the Erlang CLI. But it is this incantation. But basically, it immediately evaluates this Erlang term and then just returns. That's that stop no shell, is just so it doesn't then drop us into a REPL-based environment. And for me, it lives within Homebrew. In the Homebrew seller, Erlang, very particular version, lib Erlang ERTS, which is the library that comes along with Erlang, and then include. That path is what we need to be able to pass to our Zig to say anything in here, any of these C headers, you can actually go and use. So we'll say the Erlang path is equal to b.run. So that'd be running something outside of our build system and returning. So we'll say that. So it's a list of strings basically. Const u8 lists. Exactly as we just said a second ago. So it'll be Erlang and then eval and then IO formats part and then -s init, and then we want to stop, and we do not want a shell. So that's the Erlang path as determined by the host system. We then need to give that path to the library. That's it. Add system include path. Lovely. We'll do b.path. We'll pass that path in like so. So we've provided Erlang to the NIF library. So now we can say the NIF step depends on the NIF lib. There we go. That's a valid build file. So let's prove that is working by doing a zig build NIF. Zig build NIF. Okay. Array literal requires address of operator coerced to sling stripes. Okay, we can fix that. We just need to give it the reference. Excellent. Okay, next build step found. Build step compile. Oh, that's right. I can't directly depend on it. I need to give it the step to depend on. To give it the step to depend on. That makes sense. Let's try that again. Configuring stuff. Nice. Panicked because of the subpath. Subpath. Let's try and read this a bit more clearly. Subpath is expected to be relative to the build route. Okay, well we know that when I output this, that's not relative. That's an absolute path. So instead of a path, we could give it a CWD relative, which would be the Erl path. Let's give that a try. It built. Excellent. What did it build for us though? Let's just remove the zig out and rebuild that just so we can see. Okay, it didn't actually build anything at all. So this library isn't depended on by anything. There's nothing to actually produce. So we should add an extra step in here for something which consumes the library. So we're going to say const nif so. So Erlang expects that you have your shared objects in a .so format, not on Mac. It's usually a dylib, a dynamic library file. Those don't work in Erlang. They're expected in the Linux form. So we need to make sure we're outputting one of those. So nif so install. It's going to be an installed file. We'll say add install file with directory, and then we can say wherever that nif lib will get emitted in. Install directory will just be lib. The destination will be wherever we want to call it, which we're going to say it's going to be. We'll just call it nifty.so. So nifty. Okay, so that's not used yet. Is that good? Does it say good? Yeah, gives us a lazy path, which is what we need. So that's what would be output from the binary. Excellent. So then we need to actually use the install. So say that the step for the install depends on the nif lib step, and then the main step that we actually call, we can say that depends on the install step. Let's see what we get when we run the build from here. Oh, it's looking more hopeful. It did some extra stuff. There we go. We've got our output, our .so file. Yes, nice. Okay, so that's good. We can output shared object files, which can then be We'll get there, but when the beam can then load those, which is great. So we now need to write, so we have our shared object output from Zig. We now need a module within our Elixir app which can consume that. We'll define what methods we're expecting, and then when the NIF is loaded at runtime, those methods will be filled in and then they can be called from the Elixir side. So let's go to our NIF. We're just going to actually take this. This is going to be ours. Sorry. Goodbye world. We're gonna overtake this. So it's quite simple to load NIFs. We're just going to write a helper function called load NIF, which is going to call Erlang. This is an Erlang function, and you can see it right there, load NIF. And then we're going to say, what's this going to be? It's going to be in the Zig out directory, and it was in lib and then NIF. It will add the .so itself, so we don't need to worry about that. What's the zero? What was the 0 for? You can inject extra stuff. I think that's what the 0 is. So we'll ignore that. Okay, so that's load the NIF, and then we can, if we just put an empty implementation here, and we'll just put arrays add not implemented. There we go. One more thing we need to do is that on load of this module, a hook that's invoked, when the module is loaded, we immediately are going to load NIF. So the moment that it actually gets loaded into the runtime, boom, it goes and loads the NIF for us. We can load it and find out. So if we just do lib nif t.ex, load failed to load the NIF library. Tried, so it looked and it did no such file. Right, okay, let's get out of there, go zig lib, it's nif t, so IEX, nice clear screen. We will do the exact same command, bad library. It found it, tried to actually load it, but the library just was not in the right shape that it was expected. It just threw a paddy. So let's get out of there. Get back into the coding environment. So this side is completely fine. The Elixir side is happy to accept that shared object, but the shared object itself is just not in a good shape. It's not correct. So we need to now actually use some of the Erlang library which we added earlier from the host system. So first off, we will get that library. We're going to say Erl. It's an import from C, and it's a C include, and the name of the module is actually it's giving us all the ones that are there. So that shows that the environment is set up correctly as well, which is great. Let's just have that. So it's Erl NIF is the library that we need. Erlang NIF. Which will come from Erlang, and we can see that there's loads of stuff in here, which is nice. We're going to be using that a fair bit here, so let's assign it as a type locally. And so this add function is kind of just in the wrong shape. The arguments are not something which Erlang is ever going to give us. It needs to be refactored. And instead, the arguments that you get from Erlang are the current environment, which is like a pointer, a maybe pointer, to the Erlang NIF environment. You get an arg, which is that's a special C flavored int, and you get any additional args. Magical type of NIF term. So that's what we get from the Erlang side. So we don't have A and B yet, so I'm just going to return the number 2 for a second. And the return type is it's just going to return us a NIF term. Okay, so Zig is not happy that we are not actually using these things, so I'm just going to immediately assign these off, and then it'll stop screaming at us, and we can work in peace. So the number 2, I do not believe it doesn't seem to be actually shouting at us, but I think we need to wrap this in an Erlang. We need to make this an Erlang number 2, not just a Zig number 2. So we're going to say make a integer for us. It's going to take that environment, and then we're just going to give it that number 2. I can get rid of that line. There we go. Should be fine. And then we can do ourselves another Zig build NIF. Doesn't like us. Undefined symbol. Right, okay. It can't find the symbol. I think that's because it's loaded at runtime. It's not statically provided. It's not like in the bundle with it. It's like it's expecting it from the environment. I've searched for this before, and I know that actually this is only a Mac problem, but the linker allow shared lib undefined needs to be set to true to avoid that error. So let's just try that again. Yes. Okay, cool. Let's just output there. Still there. Excellent. We can go back into IEX. We can do our compile. Symbol not found still. Why is the symbol not found? We've got add. Right, we're still not all the way there with our definition. So this add function is fine, but it doesn't know that add function even exists. We need to provide it to the environment. So we need to expose a very special NIF init function. It doesn't take any arguments, but it does just return a special Erlang NIF entry type and return a reference to entry. We'll define it above. We can say that the entry is Erlang, exactly as we just said, NIF, Erlang NIF entry. Open that bad boy up, and then what are we needing to provide? So it needs to know the number of functions that we're going to be giving it. So we're just going to say 1 for now. It needs to know the actual functions, which is going to need to be its own. What is the type on this? It's got. If I just was to say like 1, that will undoubtedly hate me. What is it expecting? It should be a list of Erlang NIF functions. Okay, so we'll just define that up here as well. We'll say that functions is a list of 1 Erlang NIF function. So there's only going to be the 1. So the very first one is going to be an Erlang NIF. It's very wordy work. This once it's there, it'll be working. So the name of the function is add, and the arity is actually going to be 2. So you pass in 2 arguments to add, and then we need a function pointer, a pointer to the actual function, which for us will be add, which we defined above. And then finally, any flags, which we're just going to say 0. Make this wrap. There we go. Okay, so we've got the number of functions and the functions there. I don't know anything else. What else do we actually need? We need the name of what this module is going to be called, which we're going to say Elixir NIFT. And that's the, once it's loaded in, that's what the module that it's going to be loaded into is. That might be all we need. Let's give it a go and find out. Zig build the NIF. It broke. What was the problem? Expected type found that. Okay, so try and do the build again. Funcs doesn't like the fact that it's 1 like that. Okay. I think maybe that actually needs to be a pointer. Okay, different error, nice. And what is it? So it's found a const, and it doesn't want const. It wants it to be variables, so it can change. Boom, there we are, nice. Okay, so now we have that functioning. So now we have that. So now we have that built. We can go back into IEX. Let's just immediately compile. Bad lib, not compatible with the ERTS runtime 2.5717. Try to recompile. Okay. You can specify in the entry. You can specify the minimum version for Erlang. We need to rebuild. I could put a watch on this, but we're in tutorial mode. Let's go. Nifty. Still no. Okay, so I just pasted in a load of extra stuff in here that was kind of needed. So we've got like the major version and minor version of the NIF, and then just nulled out a load of values and then put in the VM variant beam vanilla, and then just an options of 1. Who knows what those means. And then also a size of the resource type. All of this was apparently needed. And then I can rebuild, rerun IEX, load it, and then we have a different error. Okay. The onload function for the module Elixir NIF returned error bad lib function not found than the NIF add to. Okay. Add not found. It's a NIF. See if implementing the 2 methods and running them in IEX is going to be enough. There we go. So it's because I hadn't actually implemented the correct one. It wasn't overwriting anything. The function had to already exist. So now, hopefully, we should be able to do nifty add, and it doesn't actually matter what I give it because we're not actually doing anything in there. 2, that 2 right there, you can see it's not implemented in Elixir. That comes from the Zig side. That comes from over here. That's our actual function here, returning an int. I can show that actually in action. This is going to be the longest debugging, the longest upgrade path for such a simple change that you've ever seen in your life, but we can prove it. Here we go. IEX. Load the NIF. Fire it off. And we get 10. Lovely. It's actually doing what it says. It's actually running the code from Zig, which is really, really cool. So now we have this boilerplate in place. We can go and implement the actual adding. We need to get the 2 values out of the function arguments, which comes from this argv. Let's see if we can make use of those arguments now. So we'll go debug and then we'll print and we'll say count, which is going to be, we'll just say any, argv0. Oh wait, no, we need to say the type, 2 types. Change until the bracket. Okay, and then it will be a tuple of the first one being the arg count, and then the actual argument itself passed to the function, and then there's one more, what could be the second one. Let's see if this actually will print in Elixir. I have no idea if it will. Compile the library. Do an add. There we go. Okay, so we see that the number of args is 2, and then the args are 31, 31. That is because they're not quite sanitized yet. So in the docs you can see, I mean this is C, but it's pretty much similar, right? We're using the C library, so we've got this nif get enif. Oh, that makes sense. I don't know why it was if then. enif, Erlang NIF, get the int, and then if it's bad, it's a bad argument, and then you can do your stuff with it. So we can do something similar. We can say, so we're expecting that there's going to actually be an A. Let's set them as far as A and B. A, which is going to be some kind of int 8. A and B, and then we're going to say that Erlang NIF gets int. The env is the first argument. The term is going to be arg v 0. Then the IP would be the position of A, and we can do the same thing again for B, like that. Let's go for that. Let's do a single line. We can say A, B, args A. Will that work? Will Zig be happy enough without us defining the type? No, it doesn't. We need that to be a type. What's it expecting it to be? That's the int. Do undefine. Let's give that a go. Value of type C int ignored. I set it as 0. Still ignored. I feel like I'm still confused by this type. It's a pointer to a list of cints. It returns a cint. Oh, can I just say const A then? B. May have misunderstood how that was supposed to work. There we go. And then we can just say A plus B. Will that build? Expected free args. What is that final argument? X to C int. Right, so it's if it worked, not to be assigned to. Yeah, so if I can do that. I'm just going to assume it worked. So I think that the thing I was missing is that returns something, and you can't just not return something. That seems to be building better. There we go. IEX, compile the module, add, just returning 10, but it's getting the correct args. Look at that. It's amazing. Okay, let's kill that, get back over here, and then let's actually implement our incredible function, A plus B, make this thing seriously useful, get rid of the debug statements. do if argc doesn't equal 2, return Erlang bad, make bad argument to the end. And you can do the same here. Like if these fail, there we go. I think that's a pretty successful add function. Let's just build the Zig for the final time. Expected time. Can I do it like that? Okay, so comparing it with 0 because it's C stuff, so it's like instead of an actual true false value, it's coming back with 0 or 1. IEX, moment of truth. Let's make this nice and big so we can see it in action. Let us compile the NIF module and finally add it together. Look at that. Love it. We can do 420 plus 69. Look at that. Lovely. I think that's even correct. Does it work with minus numbers? It does. Wow. Isn't that crazy? And then we can prove that it doesn't work with string and a number. Argument error doesn't work. That's coming from the NIF. Nice. So that proves it. That's how we can combine the raw, unadulterated power of Zig with Elixir and the incredible concurrency of the Erlang beam. That's how you can, like, with quite a bit of boilerplate involved, but once you get over that hurdle, there's a little bit of a handshake that needs to happen, but those two environments can communicate pretty fluidly. So hope you've enjoyed this as much as I have, and I'll see you in the next one.